Bismillahirrahmanirrahim. Assalamu alaikum and welcome back to Physics Mathematics Hub. Today we will solve a physics problem straight from grade 10 KP textbook, Unit 10 Simple Harmonic Motion and Waves. Let's get started with the question step by step. So here is the question. A second pendulum is a pendulum with period of 2 seconds. How long must a second pendulum be on the earth where gravitational acceleration is equal to 9.8 meter per second square, and moon where gravitational acceleration is equal to 1.62 meter per second square? What is the frequency of the second pendulum at earth and moon? We are given the time period, which is represented by capital T and is equal to 2 seconds. Gravitational acceleration on earth, represented by GE, is equal to 9.8 meter per second square, and gravitational acceleration on moon, represented by GM, is equal to 1.62 meter per second square. We have to find the length of the pendulum on earth, and part B, length of the pendulum on moon. Similarly, frequency of the pendulum on earth and frequency of the pendulum on moon. First, we have to find the length of the second pendulum on earth. Therefore, we use T is equal to 2 pi L divided by G square root, where T is the time period of the second pendulum, LE is the length of the pendulum on earth, GE is the gravitational acceleration on earth. Taking square on both sides to get rid of the square root, T square is equal to 2 pi LE divided by GE square root whole square. Applying the square and get rid of the square root, we get T square is equal to 4 pi square multiplied by length of the pendulum on earth divided by gravitational acceleration on earth. T square multiplied by gravitational acceleration is equal to 4 pi square multiplying by LE. Rearranging the formula for length of the pendulum on earth, we get length of the pendulum on earth is equal to T square multiplied by gravitational acceleration on earth divided by 4 pi square. Putting the values, we get LE is equal to 2s, which is the time period of the second pendulum, square multiplied by 9.81 meter per second square, 4 multiplied by 3.14 square, which is the value of pi. Applying square on time period, we get 4s square multiplied by 9.8 meter per second square divided by 4 into 9.86, cancelling 4 with 4, and s square with s to the power minus 2, we get 9.81 meter divided by 9.8. Finally, length of the pendulum on earth is equal to 0.99 meter, which is the required length of the second pendulum on earth. Solving the second part, here we have to find the length of the second pendulum on moon. So we use the same formula, which is Lm is equal to T square multiplied by Gm divided by 4 pi square. Here Lm is the length of the pendulum on moon, T is the time period, and Gm is the gravitational acceleration on moon. So putting values, we get Lm 2s whole square multiplied by 1.62, which is the gravitational acceleration on moon, 4 multiplied by 3.14 square. Length of the pendulum on moon is equal to 4 s square multiplied by 1.62 meter per second square divided by 4 multiplied by 9.86. Length of the pendulum on moon is equal to 1.62 divided by 9.86. Lm is equal to 0.164 meter, which is the required length of the pendulum on moon. Now we have to find the frequency of the pendulum on earth. The formula is Fe is equal to 1 over 2 pi Ge divided by Le, where Fe is the frequency of the pendulum on earth, Ge is the gravitational acceleration on earth, Le is the length of the pendulum on earth. Putting values, we get Fe is equal to 1 over 2 into 3.14 square root 9.81 meter per second square divided by 0.99 meter. Simplifying the fraction in the square root, we get 1 over 6.28 square root 9.91 per second square. Applying the square root, we get frequency of the pendulum on earth is equal to 0.16 multiplied by 3.15 per second. Finally, we get Fe is equal to 0.5 Hertz, which is the required frequency of the pendulum on earth. In part D, we have to find the frequency of the second pendulum on moon using the same formula. Fm is equal to 1 over 2 pi Gm divided by Lm. Putting the values, we get Fm is equal to 1 over 2 into 3.14 square root 1.62 meter per second square divided by 0.164. Simplifying the fraction part in the square root, we get 1 over 6.28 into square root 10.125 per second square. Further simplification gives Fm is equal to 0.16 multiplied by 3.12 per second. Finally, we get Fm is equal to 0.5 Hertz, which is the required frequency of the pendulum on moon. Note that to find the frequency of the second pendulum on earth and moon, we can also use the formula F is equal to 1 over T. This implies that F is equal to 1 over 2, which is equal to 0.5 Hertz, because as long as the time period for a second pendulum stays the same, the frequency will also remain constant. In both cases, frequency remains constant because frequency depends upon time period, not on gravity. Thanks for watching. If you found this video helpful, make sure to like, subscribe and hit the bell icon for more physics videos. Keep learning with Physics Mathematics Hub. See you in the next video. Allah Hafiz.